Hi, and welcome to Unit 2 of Physical Science, where we begin discussing atomic structure. We're going to start by learning how to navigate the periodic table, which is perhaps one of our most important skills. Before we do that, though, I want you to take some time and look at the following cars. Sort them into as many groups as you can. This is a Pear Deck slide, so you should have access to multicolored dots. If you don't, feel free to use a sticky note or to write in your notebook or in a Google document the different ways that you might sort these types of cars. I'll give you about 2 minutes to do that. Okay, so I think you've had plenty of time to sort these cars into several different subsections. Would anybody like to share the ways that they chose to sort these vehicles? Great. So now we're going to look at a periodic table. If you don't have one of your own, you can go to Google and pull up a periodic table. What trends do you recognize in the periodic table just by looking at it? Let's take another 45 seconds and see what trends we might be able to come up with in a few glances at the table. Excellent. So, what trends did you notice? All right, so now that we've had a preview of what it's like to sort things, let's talk about how the periodic table of elements is sorted. First, we need to understand what the periodic table is showing us. And what it's showing us are elements. There are 118 of them thus far that we've discovered. And elements are essentially the building blocks of matter. They cannot be broken down by physical or chemical means. The periodic table itself is broken down in two ways. The first are groups, which we can also call families. They are comprised of columns that go up and down on the periodic table. These groups are numbered 1 through 18, with group 1 having hydrogen at the top and group 18 having helium at the top. They can also be grouped A and B with a Roman numeral. The second sorting of the periodic table are periods, which are the rows that go across on the periodic table. These are numbered 1 through 7. So if we were to look at this periodic table, for example, we see both the groups or families labeled 1 through 18, and then we can also see the Roman numeral sorting with groups A and B. Our taller columns, 1, 2, 3, 4, 5, 6, 7, and 8, are all A columns. Our transition metals, or this shorter block in the center, rows 3 through 12, or columns 3 through 12, I'm sorry, are all B grouping. That does include these two rows that have been pulled out from here and here. So for example, if we were to look at arsenic, which is number 33 on the periodic table, we would say that it is in group 15, and then period 1, 2, 3, 4. So arsenic is in group 15, period 4. That's how we discover where an element resides on the table. So let's just do a quick check. Everyone should have a periodic table pulled up. Go ahead and tell me, we'll do this in about a minute. Tell me, well, let's do a minute and 30 seconds. Take some time looking at your periodic table and tell me what element is found in each group and period. All right, and that's time. So what elements do we discover using these brief descriptions? Okay, so we've talked about the ways that the periodic table are sorted into groups and periods. The elements themselves are also sorted on the periodic table. Before I tell you how they're sorted, let's think about a few different substances and how they act. Metals are good conductors of heat and electricity. They have a high luster or shine. They are ductile, which means that they can be hammered into flat sheets like aluminum. And they are malleable, which means that they can be manipulated into wire shapes. Think like wire or copper. I'm sorry. Nonmetals are poor conductors of heat and electricity. They are very dull and bitter, brittle. Metals are good conductors of heat and electricity. They have a high luster, so they're shiny, and they are ductile, which means they're capable of being shaped into wire like copper, or malleable, which means that you can hammer them or press them out of shape without worrying about them breaking like aluminum. Nonmetals are poor conductors of heat and electricity. They're dull and they're brittle. And our metalloids, which are located on the staircase of the periodic table, have properties that are similar to metals and nonmetals, but they are mediocre conductors of electricity, so we call them semiconductors. So, how then do we classify the elements? Well, we give each group or each family a name. Group 1 are the alkali metals. They are very reactive and they're soft solids. Group 2 are our alkaline earth metals. Groups 3 through 12 are what we call the transition metals. Group 17 are the halogens. And group 18 are our noble gases. The elements were sorted into these columns, groups, families, because the elements in these groups have similar properties. Group 1 is all alkali metals because they are all soft solids, they're all highly reactive. Just like in your own family, where you might have a similar hair or eye color, or might have similar height or nose. Our elements share features with the group members that they are next to. So, our general consensus is that elements in the same group have similar chemical properties. Elements on the far right, our noble gases, are the least reactive, and elements on the far left, our alkali metals, are the most reactive. For your exit ticket, please use these elements listed above, as well as your periodic table, and tell me whether or not an element is a metal, a nonmetal, a metalloid, whether it's a poor conductor of electricity, a gas at room temperature, a solid at room temperature, ductile or malleable, a liquid at room temperature, or does it have properties of both metals and nonmetals using your periodic table? So, for example, Mg, which is magnesium, is a metal, a solid at room temperature, and is capable of being drawn into wire or hammered into thin sheets. So I would say Mg167 in my notes.